So one more aspect which has to be taken care here is, students, that is EAN rule. EAN rule. That is, this is effective atomic number rule. Effective atomic number. So this is basically proposed by Warner, the scientist Warner. That is, it comes under the Warner's theory. So in the Warner's theory, if you consider, he has spoken about the EAN rule, which is for speaking about the stability of the complex. That is, you will be having, if the complex satisfies EAN rule, you will find it's of higher stability compared to the one which is not satisfied by the EAN rule. That is, EAN rule is effective atomic number rule. What it says is, central metal ion will keep accepting the electron from the ligand till it reaches the next noble gas configuration. Till it reaches next noble gas configuration. Next noble gas configuration. Central metal ion or the central atom, central metal ion continues to continue to accept electrons from the ligand. So it's very simple. That is, central metal ion, you see, the ligand does donate the electron to the central metal ion, right? Ligand does donate the electron to the central metal ion. So what the EAN rule says is, the central metal ion will keep accepting the electron from the ligand till it reaches the next noble gas configuration. That is, next noble gas for the first group is 36, right? That is, we have the noble gas, helium, neon, that is argon, krypton and xenon, right? Krypton and xenon, right? Krypton and xenon. This is 36 and this is 54, right? This is 36 and 54. So first group central metal ion, for example, copper. Very simple. Copper, what is the atomic number of the copper? Copper is having the atomic number 28. In this particular complex, if you consider, how many electrons the central metal ion or the copper has lost? Copper has lost here. How many electrons copper has lost? Copper has lost, this is copper, right? 29, right? 29. Copper has lost how many electrons here? 2 electrons it has lost, because the copper has become copper plus 2 in this complex. What is the charge on the complex, or the oxidation number of the complex here is plus 2. That means the oxidation number of the copper is plus 2, or the charge on the copper is plus 2. That means it has lost 2 electron. So it has lost 2 electron means atomic number is 29. That means it has 29 electron, but it has lost 2 electron during the formation of the complex, that is 27. So now, to reach 36, how many electrons it has to accept? It has to accept how many electrons? That is, it has to accept 9 electrons has to be accepted. 9 electron has to be accepted by the copper. What the EAN rule says that, so the central atom, that is the copper, will keep accepting the electron from the ligand till it reaches 36. That is what the effective atomic number rule is. That is what the effective atomic number rule is. That is, EAN rule or the effective atomic number rule is, the central atom will keep accepting the electron from the ligand till it reaches the configuration of the electronic configuration of the next noble gas. If it is a 3D group transition element, it will accept the electron till it reaches the next noble gas configuration, that is 36, right? If it is a 4D group, it will keep accepting the electron till it reaches 54, and so on and so forth. Very simple, not a difficult one. For example, here, what is cobalt ion? Cobalt ion is in the plus 3 oxidation state. That is, 27 is the atomic number of the cobalt. If you take out 3 electron, that it turns out to be 24, that means it has to accept 12 electron to reach 36. What the EAN rule says that cobalt will keep accepting the electron from the central, the ligand till it reaches 36. That is what is called as EAN rule. Some of the complex will satisfy the EAN rule, some complex will not satisfy the EAN rule. Or they may ask you, based on the EAN rule, which of the following complex is highly stable, they may ask you. One which satisfies the EAN rule, we consider it as to be stable. One which doesn't satisfy the EAN rule, which considered to be unstable complex. That's it, very simple. So how do you write the EAN rule? EAN rule is the central metal ion keep accepting the electron till it reaches the next noble gas configuration. Or they may ask you to find out EAN number. EAN number is the same thing, that is EAN number is atomic number of metal, atomic number of central metal ion, atomic number of metal ion minus charge of the metal ion, or electrons lost during the complexation. How many electrons lost, or how many positive charge it is having, plus electrons gained, right? Electrons it is gained, central metal ion gains the electron from the ligand. But during the complexation, it will be losing the electrons and it will have some positive charge. Sometimes it will be having neutral also. For example, nickel tetracarbonate. In that, electron lost is 0, right? So likewise, EAN number may be asked you to find out. Few of the competitive examination, you will find it. That is, what is the EAN number of this complex? What is the EAN number of this complex? Can we calculate? Copper, what is the atomic number of the copper? 29 is the atomic number of the copper. It is plus 2 charge, that means it has lost 2 electron. How many ligands we are having? We are having 4 ligands. That is 4 monodentate ligand, that means 4 coordination bond. 4 monodentate ligand will be giving 8 electrons, that means a ligand will be giving 1 pair of electron. That means total number of electrons given by 4 ammonia molecule is 8. That means 29 minus 2 plus 8 turns out to be 37. Minus 2, that is 35, right? 37 minus 2, the 37 minus 2, it is 35. That means EAN number in this complex is 35. Does it satisfy the EAN rule? No, it doesn't satisfy the EAN rule. To satisfy EAN rule, that is the EAN number of the complex has to be 36. But it doesn't satisfy. In that basis, we can say this complex is less stable. Why this is less stable? Because it doesn't satisfy the EAN rule. They may ask you, based on the EAN rule, predict the stability. If it doesn't satisfy, it is not stable. If it satisfies, it is stable. For example, this complex, let us take a look, students. In this particular complex, cobalt we are having. What is the atomic number of the cobalt? 27. How many electrons it has lost? Cobalt is in the plus 3 oxidation state. That means 27 minus 3. How many electrons given by the ligand? Each ligand is a monodentate ligand, ammonia is, each ligand will donate 2 electrons. That means 6 ligands we have, it can donate 12 electrons. That means we have 27 minus 3, that is 24. 24 plus 12 is 36. That means it satisfies the EAN rule. That is, EAN number of this particular complex is 36. That means it satisfies the EAN rule. So based on the EAN rule, we can say this particular complex is more stable compared to this. Clear? Because this is having a EAN number. Next noble gas configuration, it is reaching. In this case, what is happening? Cobalt is in plus 2 oxidation state. That is 27 minus 2. How many ligands we have? 6 monodentate ligand, 12 electrons. So this is 35, right? This is 35. 35 or 37? Right, 37, I'm sorry, this is 37. Again, it doesn't satisfy the EAN rule. EAN number is, if they are asking what is EAN number of this, 37. But it doesn't satisfy EAN rule. Based on the EAN rule, we will be saying, effective atomic number rule, we can say this complex is unstable. Right, in this particular complex, K4 FeCN6, right, K4 FeCN6. So that is iron, atomic number of iron is, what is the atomic number of iron? 26 is the atomic number of iron, right? Cn minus ion. What is the charge on the complex, or what is the oxidation state of the ion here? +2. We have calculated that, right? Charge on the complex is -4. Charge on the complex is -4. This is +6. So the ion, the oxidation number of the ion is +2. That means 26 -2, because it has lost 2 electrons. How many electrons it has gained? 12 electrons it has gained. That means it is again 26 plus 12, that is 38 minus 2, that means it is 36. So it is EAN number of this particular complex is 36, or in other words, the central metal ion has accepted the electron till it has reached the noble gas configuration, that is a krypton configuration it has attained. That means it has attained the krypton configuration, or this particular complex is a stable complex based on the EAN rule. So how about this? This is 28. Atomic number of nickel is 28. How many carbonyl group we are having? That is, how many carbon monoxide ligands we are having? 4 carbon monoxide ligand. It's a monodentate ligand. That means each ligand will be giving 2 electrons. 4 ligands will be giving 8 electrons. No charge on the complex. The central metal ion is in the zero oxidation state, or in other words, 28 plus 8 is 36. So this is stable based on the EAN rule, because the EAN number turns out to be 36. Very simple, very clear. I'll repeat again. So what and all satisfies the EAN rule? This satisfies the EAN rule, this satisfies the EAN rule, and this particular complex satisfies the EAN rule. These two complex doesn't satisfy the EAN rule. So based on the EAN rule, we can say these two are unstable. That is, it is 35 is the EAN number, 37 is the EAN number, rest of all cases it is 36. This is how, students, you can calculate the EAN number for a coordination complex. You have a EAN rule, so till it reaches the next noble gas configuration, it will keep accepting. Need not to. In all the complexes, the central metal ion doesn't do so. If that is so, if it is not doing so, we will say based on the EAN rule, it is unstable. It may be stable because of the various other reasons, but this is a gross prediction which is done by the Werner. Okay, so this is all about the EAN rule, that is effective atomic number rule, and the EAN number. Two things may be asked. One is directly EAN number may be asked to calculate, or what is the EAN rule, or based on the EAN rule predict the stability. These are the questions could be raised in this particular area.